The following video is about inverse variations and reciprocal functions. Inverse variations happen when the product of two variables is constant. The equation for inverse variation can be written in two different ways. The first way is x times y equals k, where k is the constant that the product is equal to. We can also write this equation by solving for y. So y equals k. To isolate y, we need to divide by x. Now, three things must be true in order for us to have the variation that's an inverse. The first is that the product of the x and y has got to be equal to the same number. The second thing that happens is k can't be equal to 0. And if k can't be equal to 0, both x and y can't be equal to 0. Here we have the problem. X and y vary inversely when x equals 4 and y equals 12. We need to find the function that models the variation, and we're also going to graph the function. The first thing we need to do is we need to find k. And if we know that x times y equals k, 4 times 12 equals 48. So the equation for our inverse variation is y equals 48 over x. Now that I have this equation, I can make a table of values for my graph. And I'm going to pick values of x that I know go into 48. So then I know that I can avoid fractions. So the first number I'm going to choose is 16. Because I know 16 times 3 is 48. 12 times 4. 8 times 6. And then the reverse is also true. 6 times 8. 4 times 12. 3 times 16. So when I make my graph, here's my x-axis, here's my y-axis, and I'm going to count by 2s to make sure everything fits. On both axes. So now I'm going to plot my points. 316, 412, 6, 8, 8, 6, 12, 4, and 16, 3. Inverse variations make a curve. This is not a linear relationship. This is an inverse variation relationship. And two things you got to make sure happen that don't happen. You have asymptotes here. Remember, x and y are not allowed to be equal to 0. The second type of function we're going to talk about are reciprocal functions. And reciprocal functions are very similar to inverse variations. Their graphs are going to follow a very similar pattern. So the first thing we need to talk about are the restrictions. Since we have a fraction and our variable x is in the denominator, we know that x can't be equal to 0. And if x can't be equal to 0, that means y also can't be equal to 0, because there's no point we can plug in for x that'll give us a y equal to 0. The next thing I'm going to do is make a table. And the points I'm going to plug in are -2, -1, -1/2. I'm going to skip 0 because 0 is not allowed. 1/2, 1, and 2. When I plug in -2, I'm going to get -1/2. Plug in -1. When I plug in -1/2, I get 1 over -1/2. Since I have a fraction in the denominator, what I'm going to do is I'm going to take the reciprocal of this. So this is equal to -2. When I plug in +1/2, a similar thing happens. We end up with a reciprocal. 2, 1, and then 1/2. When I go to make my graph, the first thing that I need to lay down are asymptotes. You're going to have 2 asymptotes for reciprocal functions. The first one is going to be at x equals 0. So we have a vertical asymptote. And we also have a horizontal asymptote at y equals 0. So again, reciprocal functions have 2 asymptotes, both a vertical and horizontal. And then I'm going to go ahead and plug in all my points. -2 1/2, -1, -1/2. And our graph is going to have a similar shape to the inverse variation. The only difference is we have a positive side to the graph and a negative side. Make sure your graph does not cross your asymptotes. We're not allowed to have any x values equal to 0. We're not allowed to have any y values equal to 0. And your graph needs to represent that. Make sure your function does not cross through your asymptotes. Reciprocal functions can have the general form a over x minus h plus k. So what's going to happen is the h value will shift our function left and right. The k value will shift our function up and down. We're going to have 2 asymptotes. The vertical asymptote is going to be at x equals h. It's the opposite value for what we have in our function because we're not allowed to divide by 0. But the horizontal asymptote is going to be the same value as k. Because our asymptote's usually at 0, and the k value shifts us up and down, so the vertical asymptote's either going to move, the horizontal asymptote's going to move up if k is positive, or it's going to move down if k is negative. Now we're going to create a graph for the function y equals 8 over x plus 3 minus 2. We're going to start this graph by creating a table for the parent graph. The parent graph, you just ignore the h and k values. And then we'll shift our table later just like we did with the log and exponential functions. So my parent graph is y equals 8 over x. And I'm going to choose a few values that will fit in my function. So I'm going to choose 8, 4, 2, and whatever values you choose, you also need to do the negative. So -2, -4, -8. If you don't do the negatives, you're going to be missing half your graph. So when I plug those values in, I get 1, 2, 4, -4, -2, -1. And then I'm going to need to create a new table for my shifted function. The horizontal shift is going to be 3 to the left, so I'm going to take away 3, and down 2. So I'll take away 2 from all my y values. So again, taking away 3 from all my x values. And then taking away 2 from all my y values. The first thing that needs to go onto your graph are your asymptotes. And my asymptotes are going to be x equals the opposite of my k value, so -3. The reason why it's -3 is if we plug that into the denominator, we get 0. And that's not allowed. Can't divide by 0. And the the vertical asymptote is going to be at the k value. So those are the first two things that go on your graph. Vertical asymptote at x equals 3. Make sure you label it with its equation. And the horizontal asymptote at y equals -2. Then I'm going to go through and plot my points. 5, 1, 1, 0, 5, -1. 5, -1, 1, 0, -1, 2, -5, -6, -7, -4, and 11, -3 is not going to fit on my graph, so I'm going to leave it off. And here is the shape of the graph. Again, it's a curve, it's not a line. Make sure your graph does not cross your asymptotes. And there we have the graph of y equals 8 over x plus 3 minus 2.